Hello everyone. This video would focus on graphing cubic equation in vertex form, and this is the second part. In this part, the absolute value of a is greater than 0 and less than 1. Before we go farther, please feel free to check out the description box below for the link of the other series of topics related to graphing cubic equation in vertex form. Before we jump into this example right here, let's have a review on the basics of cubic equation in vertex form. We remember that the vertex form or the graphing form of a cubic function is given in an equation y equals a quantity x minus h cubed plus k. Now let's look at the effects of the parameters a, h, and k to the graph. So this is the graph of a cubic equation. So we remember that this graph has two tail ends. The other end is pointing upward, while the other end is pointing downward. Now we remember that if A is positive, the right end of the graph is facing upward. Now, when A is 0, the graph is a horizontal line. Whenever the A is negative, the left tail end of the graph is directed upward. Now, we also remember that this parameter A is called a stretch factor. It causes the graph to be vertically stretched, which makes it narrower, or it makes the graph horizontally compressed, which makes it wider. Now, we remember that the closer the value of A is to 0, the wider the graph becomes. So if you notice, we started from the negative end or the negative side, and we're approaching 0 right now. The graph becomes wider and wider to the point that at 0, it becomes a horizontal line. And that is true on the other side as well. So if we start from 10, we go to 0, we're making the value of A closer to 0, then the graph becomes wider and wider up to a point that at 0, it becomes a horizontal line. On the contrary, the farther the value of A from 0, then the graph becomes narrower and narrower. So as you can see, it becomes narrower right there. Now, if we start from 0, we go the other way, it becomes narrower and narrower as we go farther from 0. Now, we also remember that the coordinate hk is the vertex or the locator point of the graph, where our h translates the graph left or right, while our k translates the graph up or down. Okay, so we go over this problem right here. So we're supposed to sketch the graph for this. The first step here is to determine the vertex or the locator point. So I'm going to go ahead and write that down here. The coordinate of the vertex or the locator point is hk, and this is our h and this is our k. The trick to write the coordinate would be we switch the h, so that comes out 3 positive because it's a negative, and then keep the sign of this, and that would be 4. So this is our vertex or the locator point of this equation. The second step is to create and complete the table of values. I'm going to go ahead and draw the table down here. We are going to fill these blanks in. So we start with the vertex. It's going to be placed in between these blank boxes here. So we go ahead and write 3, 4 down here. And then we go up. That would be 4 and 5. Then we go down to the other side. That would be 2 and 1. Our next task is to determine the values for the rest of these blanks here, which are the y values. So I'm going to go ahead and show the work down here. We're going to start with x is 2, and we will solve for y. So x is equal to 2, and we're solving for y. We're going to use this equation right here, but we're going to change this x into 2. So this would come out y equals 1/3 in decimal is 0.33. So we can use that. So 0.33. And then that would be our x minus 3 cubed plus 4. So we put in the value again of 2 right here. So this would come out 0.33 2 minus 3 is negative 1, and then cube it plus 4. So we got 0.33. Negative 1 cubed means negative 1 times negative 1 times negative 1, which comes out negative 1. So I write negative 1 right here plus 4. 0.33 times negative 1 is 0.33, and then that's gonna be plus 4, so this comes out 3.67. So the value that we're gonna have here would be 3.67. So we go ahead and solve for the value of y when x is 4. So I'm gonna show the work on the side right here. So the value of y when x is 4 is 4.33. Now we are going to determine the rest of the values here when x is 1 and when x is 5. And I'm going to show the work on the bottom side right here. Okay, so the values that we have here for 1 is 1.36 and for 5 is 6.64. Now, please notice this very carefully. 1 minus 3 is negative 2. Negative 2 cubed means negative 2 times negative 2 times negative 2 is negative 8. And so negative 8 times 0.33 is negative 2.64 plus 4. That comes out 1.36. So the next step that we're going to do is to sketch the graph. So we're going to start by sketching the vertex, although you can start anywhere. It doesn't really matter. So let's start with the vertex. So it's going to be on 3 and 4. So it's going to go all the way up here. And then the next dot would be on 4 and 4.33. So that's 4. 1, 2, 3, 4. 4.33 should be down here. And then we have 5 is to 6.64. So that's 5 and then 6. 6.64 should be approximately somewhere there. And then we go down the other side, which is negative 2 would be 3.67. So 1, 2, 3.67 should be somewhere around here. And then we have 1 is 1.36. So that would be 1 here and 1.36 is down here. So we are going to sketch the graph of this equation. Now, please notice that this graph is going to go all the way to the right to the infinity and all the way to the left towards infinity. And at the same time, this is going to go up to infinity and go down to infinity. This tells us that both the domain and range for this graph would be all real numbers. So I'm going to go ahead and write it down here. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to determine the vertex or the locator point. I'm going to go ahead and write that down here. We remember that the coordinate of the vertex is HK. This is our H, this is our K. To determine the coordinate, we switch. So this comes out negative 5 and keep, that would be negative 4. So this is where our vertex is going to sit. The second step is to create and complete the table of values. I'm going to go ahead and create the table of values down here. We are going to put this vertex or locator point in the middle of this table here. So this would be for negative 5 and this is for negative 4. So we go up, that would be negative 4, then we go negative 3, then we go negative 6 and negative 7. Our next task is to determine the values for y given these x values here. So we go ahead and show the work on the side here. We're going to start with x is equal to negative 4. So I'm going to write that up here. X is equal to negative 4. So what we do is this negative 4 shall be plugged into the x here. So I'm going to write the equation y equals 1/2 is negative 0.5 if you use the calculator for that. So that would be plus 5 cubed minus 4. So again, our x is negative 4. So I put that in there. So this would come out negative 0.5 times negative 4 plus 5 is positive 1. So that is cubed minus 4. So this comes out negative 0.5. 1 cubed means 1 times 1 times 1. That would be a positive 1 minus 4. So negative 0.5 times 1 is negative 0.5 minus 4 is negative 4.5. So this is the value that we put in here. So when x is negative 4 is negative 4.5. I'm going to show the work when I have to solve for y when x is negative 6. So I will put that in here. X is negative 6. Then I'm going to show the work down here. Okay, the value for y when x is negative 6 is negative 3.5. So please notice this. Negative 6 plus 5 is negative 1. Negative 1 cubed means negative 1 times negative 1 times negative 1 is a negative 1. So negative 1 times negative 0.5 is a positive 0.5 minus 4 is negative 3.5. Now we are going to determine the value for y when x is negative 3 and x is negative 7. And I'm going to show the work down here. Okay, so these are the values for the table that we have right here. The next step is to sketch the graph. So we start from the vertex. Again, you can start anywhere. We start from the vertex here, negative 5, negative 4. So that would be negative 5 down here, and then we go down to negative 4. So this is our vertex right here. The next dot is negative 4 and negative 4.5. So negative 4 and negative 4.5 is down here in between the negative 4 and negative 5. So this is our negative 4.5. Negative 3 goes with negative 8. So that would be negative 5, 6, 7, 8. So it's going to sit right here. And we go the other way around. That is negative 6 goes with negative 3.5. So negative 1, negative 2, negative 3, negative 3.5 is in the middle right here. And then we have negative 7 is 0. So it's going to sit down here. So we're going to sketch the graph of this equation. So this is the graph of this equation that we have right here. So please notice that this graph is going to go towards the infinity on the left, and it's going to go infinitely to the right, and it's going to go up infinitely, and then it's going to go down infinitely as well. So this tells us that both the domain and range for this graph would be all real numbers. So I'm going to go ahead and write that up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!